Okay. So what this was going to be um, was a tutorial into um, this software that's freely available, um, Wolfram Alpha. So the reason that I decided to kind of focus on this is that there's a more powerful version of this called Mathematica, which Piedmont has a license to, and then and actually shows up in different courses. So physics courses, Calculus 3 uses it. And so I wanted to do a little bit of an introduction, especially as we move into the applications of um, integration section. A big part of what we're doing is finding the right integral, and in a kind of realistic situation, you would figure out what integral represents whatever I want to find, and then you would have some software actually do the computation for you. So in Wolfram Alpha, it tries to be really natural language. So I can type something like factor a polynomial. I'll pick this one. And so what it tries to do is guess or come up with an answer to your question, but also other questions that you might have if you're trying to factor something. So it has the kind of standard factorization, but it also says, well, what if you want to factor over the complex numbers rather than just the real numbers? It says here are some different plots where you might want to, if you're factoring, you might be interested in zeros. So we see the 0 of -2 and then this inflection point. But you also might just want to know about the graph more broadly. And we can see the end behavior in this bigger picture. A lot of times what also shows up is some more advanced things that we won't really be using. So factorization over finite fields. A finite field is kind of a setting where you can do algebra, but instead of the infinitely many real numbers, you only have finitely many things, which some people are interested in, we are not. So a lot of the pieces we can just kind of ignore. But these two blocks here suggest we can do a lot of graphing within this. And there's a really natural command plot, and I'll say, let's do e to the x over x squared plus 1. So Wolfram Alpha tries to be a lot of different things. So it's a very powerful calculator. It's also a graphing calculator. It's also a little bit of an encyclopedia. And I think, what else can we do? So looking at other things that it can do, solving equations is something that it's good at. And this is especially useful if we have something like 2 to the x equals x plus 4x squared, which is an equation that there just isn't algebra to solve it. We can't handle this exponential function and this polynomial part in the same equation. So the only way to really try to solve this is by approximating, looking at the graph. So this has a couple solutions. Here we can see these different solution points and their approximate values, and it can let's see, get some more digits so you can play around and get different kind of answers to your question. it can also handle easier things. So if we put in a quadratic, which we could always just use the quadratic formula, x squared minus 4x plus 6, it will do that for us. And some other pieces that we maybe aren't so interested in. If we don't have this solve in here, which you might guess, if you were just given this equation, you might just write it down. Wolfram Alpha tries to guess what you want to do. So some of that is solving it, and here we have the solutions here. But it's also saying maybe you want to factor it, and we have these different forms, including this like completing the square version. You might want to graph it and see that it doesn't have any real solutions. So it tries to interpret what you're actually asking it to do. And so a big part of this is trying to figure out what it can actually do. And if we go into this examples thing here, this has a list of all the different things that that are included on this website. Some of it is non-mathematical. I think when I was playing around with this, I looked up food and nutrition, and it can try to give nutritional information for food. So it tries to be really comprehensive, but where it really shines is in some of these mathematical tools. And so if we were wanting to know what kind of algebra can it do, it has things like solving equations. And here this would let us see something like how I write solve this equation is have the equation and write solve as the command in there. But it can handle a lot more than that. It can do things like solving systems of equations, and that's where we just write both equations in there and it tries to solve it. Other more advanced stuff below, but simplifying and expanding, like it'll multiply something out or factor it. A good example for us is it can do partial fractions for us. And so this would be the thing you'd be like, huh, I wonder if it can do partial fractions. And the first guess might be, let me just write in partial fractions and my rational function and see what happens. But if you're ever not sure, kind of a skill which is actually important is figuring out what software can do. And some of its own examples is a place to go, or Google Wolfram Alpha partial fractions, something like that. Like Wolfram Alpha partial fraction, and just see what it says. And it'll direct you to the right place in there, or some other links. And so this has a lot of different pieces. Maybe the most important parts, here it has the completely factored version. So before you jump into the partial fractions, you would want to factor at least the bottom as completely as you can. And then it has the full partial fractions with all the constants in there. So besides just doing a bunch of algebra, there's what kind of calculus can this do? And one place to search is if you just type in limits and see kind of what it says. So for some things, it has a particular or in this case, it offers up a particular input, which just says, here's a function, here's the value. It can do this limit. So if we change that cosine of x over x at 0, we can ask it to run it, and it has all of this information. So it has the actual values. It says the limit doesn't exist because it looks at it from the left and the right. It gives you the graph and some other stuff, which we aren't super interested in right now. So it can do these limits for us. But you might also ask, I'd have to find this place first, and I'd rather just know, what do I type in here to make it do a limit? And so for that, we could check, it has in its examples some calculus, and what we can really look for is limits. It has these ready-made examples, so we can see the documentation here. So we can write lim or limit, and then as the variable does whatever we want it to do. So if we want this limit sine x minus x over x cubed, we would write in lim, or limit would also do the same thing. Our function that as x goes to 0. And now we don't have to find that particular page, we can just type it in. If you go back to that place, it also has some derivative examples, and there are a couple of ways of entering that. You could write differentiate, or you could write d dx, and if we try to take the derivative of x squared sine of e to the x, so some big chain rule and product rule problem, it'll do this all for us and give us the graph. This bottom graph looks weird, but what's happening is it's doing this crazy oscillation so fast, it looks like it just fills up the entire graph. But we can see it sort of closer up, it's starting to oscillate there. And a lot of other information, the roots, the indefinite integral, which is the reverse of what we did. So it can do all of these derivatives. And you can look up what other kind of variations can we do. So for instance, we might want to find the derivative at a particular point. So find this at natural log of 3. And so it goes ahead and it finds the derivative, but then it substitutes that value in and gives us, I guess this graph they're saying is the derivative, and this is that height at natural log of 3. So where this I think is really useful is in integration, because derivatives, we could find this derivative if we wanted to using the appropriate rules, but integration is a lot harder. And this is really nice in that if we just want to integrate, we have to just tell it to integrate this function, x to the 6th over 7x, or plus 7x, does the power rule for us. And even more than that, if we look at, say, x to the 6th times sine x, this, if we want to look at it, or if we want to do this, this would be an enormous integration by parts. So like x sine x was integration by parts, x squared sine x, we did it twice. This we'd have to do 6 times, which we really don't want to do, but here this will do it for us. And it's a little weird because it decides how it wants to group things. So maybe the best form would be this, what it's calling the expanded form. And here we can kind of see the partial fractions happening, or not the partial fractions, the integration by parts, where these powers keep going down, like we're differentiating those powers and we're integrating the trig function. So we're going from sine and cosine and bouncing around. It's also good because there are some functions like e to the x squared. So not a really complicated function, but what happens is that it doesn't have a nice antiderivative. And it's not that we just don't know what it is or we haven't found it in this class, but some, I think, French mathematician proved 150 years ago that it doesn't have one. Like you can't write it down. So this is where the numerical stuff is really helpful. Some things in here, so there are other ways of representing this function than a nice single expression for the integral. Series is something we'll talk about. But what's really nice is maybe you don't care about the antiderivative, but you want to find a definite integral. So if we say, let's integrate this from 0 to 2, it can give us an approximation for the corresponding area for the definite integral. So especially for situations where you can't find the antiderivative, you're really stuck having to do something numerically, and for that you have to turn to whatever software is available. And maybe as a last example, so it can do even more. And give you check-in. Let's go in here, examples. What else can calculus do for us? Applications, area bounded by curves. So even if you just said, what is the compute we don't really need, but area between these two functions, it provides the graph, it figures out what the intersection points are, 3, -3, sets up the integral, and then actually computes the area. So a lot of these applications, in this case, there's a sort of standard way of coming up with this integral, but in some situations, you might figure out what integral do I want this to do, and then feed it in, and it'll give you a number out. Yeah, so this is, I might be using this, or as we start doing some applications, just to kind of show if we can get the integral down, then there's a way to do it. But it's a good thing to start being exposed to. The calculus we're learning is why all of these things work. But if you want to use them for something, you'll really use some kind of software similar to this. Any questions or any kind of, I guess a question you might ask is, what else can it do? And so depending on what you feel like, or what uses you have for it, it can do a lot of graphing. It's a basic calculator. I think a place where it has a lot of use is statistics. So finding the average of a bunch of data points, or things like standard deviation and variance or other statistical quantities. And this has a nice way of doing all of those calculations at once. Yeah, so this was the kind of short tutorial to give a little exposure for the software, that this or a more powerful version can be useful if you ever need to use this the math or calculus in particular for something that you're doing. Cool. Yeah, so that was all.